4.2 lecture, we'll deal with the unit circle. And so you'll notice they talk about this circle, um, x squared plus y squared is equal to 1. So this is talking about a circle with radius 1. So if I go to the right, 1, that's why x is 1 and y is 0. If you go up 1, x is 0 and y is 1. So those are the very first ordered pair that you know, and we'll also talk about, when you look at it, the unit circle helps me determine what's cosine and sine. So once I have cosine and sine, I can do all 6 trig ratios from each spot. So cosine, sine. We want the degrees, we want radians, we want an ordered pair. And so let's see if I can do this quickly for you. So typically when I do a unit circle, I'll start with my degrees, and maybe we'll do those on the inside. So the very first one, the positive x-axis is 0 degrees, and if you go all the way around, that's 360. Each quadrant is 90 degrees. So if you just keep adding 90 all the way around, you can do your 4 quadrants. In 4.3, we talked about some of those special triangles, the 45, 45, 90, and the 30, 60, 90. So these angles out here are 30 degrees, 45 degrees, and 60 degrees. Now, the key to understanding the unit circle is that every quadrant has a 30, a 45, and a 60. You just build from the x-axis. For instance, in quadrant 2, I would go from the x-axis and I would go this direction, which is actually backwards or in the negative direction. So when you lift from 180 up 30 degrees, you're actually going to subtract there. So this, even though we say it's 30, we call it 150 degrees. Because it's 30 from the x-axis. This would be 135 degrees, 30 from the x-axis, and this would be 120 degrees, 60 degrees from the x-axis. Now in the third quadrant, you're continuing in what we'd call the positive direction. So now you're going to add the same angles. So when I add 30, I get 210 degrees. When I add 45, I get 225 degrees. When you add 60, you get 240 degrees. So every quadrant has a 30, a 45, and a 60. Now, when I move to the fourth quadrant, I have to work from the x-axis, and so I would have to subtract, go in the negative direction. Remember, positive x-axis, if you go down and around, that's negative. So we're going to be subtracting here. And so if I subtract 30 from 360, I get 330. And if I subtract 45, I get 315. And if I subtract 60, I get 300 degrees. So those are the angles, and typically students are fairly comfortable with those. The radians kind of do the same thing. We're going to do 0 or 2 pi. And then half of the circle, so if I just do the top half to here, half of 2 pi is pi. And then looking at the top half of the circle, I just want half of it. So we would say half of pi, or pi over 2. So pi over 2, so you can start at the beginning and go 0, pi over 2. 1/2 plus 1/2 is 1, that's why that one's pi. And then the one down here would be 3 pi over 2. Now, when you look at the first quadrant, we're looking at the top half of the circle, and I would say how many 30s can we fit in 180? And that's 1. Or 6, I mean. But so this represents a sixth of the top half of the circle. And how many are there? You can write 1 pi if you want, but we typically just write pi. How many 45s can you fit in 180? And that's 4. And so then this would be pi over 4. And how many 60s can you fit in 180? 3. So now that's pi over 3. Well, the nice thing about the radian measure, even though we're not very comfortable with it, is that all the denominators stay the same. If you're talking about a 30-degree angle, it's something over 6. So at 150, it'd be something over 6. At 135, it'd be something over 4. And at 120, it's something over 3. So you can see the denominators from the x-axis always go 6, 4, 3. At 150 degrees, I just asked the question, how many 30s can you fit in 150? And that would be 5. So that would be 5 pi over 6. At 135 degrees, how many 45s can you fit in 135? That would be 3. And then the 120, you would ask, how many 60s can you fit in 120? That would be 2. So once you get the pattern for radians down, it's not too bad. So again, this would be over 6, this would be over 4, and this would be over 3. Now, how many 30s can you fit in 210? 7. How many 30s can you, or how many 45s can you fit in 225? That'd be 5. And how many 60s go in 240? That's 4. Fourth quadrant, we do the same thing. A 6, a 4, and a 3. How many 30s can you fit in 330? 11. How many 45s fit in 315? 7. And 300, how many 60s fit in 300? 5. So there's your degrees and your radians. And so I typically put degrees in there and then the radians around it. Now when we do the order pairs, we did the ones up above. Going to the right, my x would be 1 and my y would be 0. Going up, my x is 0, my y is 1. Going left, negative 1, 0. And then at the bottom, try to squish it in here, 0, negative 1. Now those 4 that I just did, the top, bottom, left, to right, are actually some of the most commonly missed ones because you concentrate so hard on other order pairs that you forget to mark the top, the bottom, the left, and the right. So make sure you get those in there. That's because the radius is 1. So just moving away from the origin 1, up, down, left, or right. The rest of the order pairs out in the middle can be found using your special triangle. So I'll just draw one quick. If I draw a right angle here, perpendicular back to the x-axis like we talked about in 4.3, my theta would be here. My theta right now is 30 degrees. So if that's 30, then this angle up here is 60. And so if my unit circle has a radius of 1, this side is 1/2, this side is √3/2. Now we don't want to have to do this every time we do an angle, but that's what it is. Now my x value is how far did I go to the right, so that's √3/2, and this is my y value, how far did I go up? 1/2. Now one last thing you want to kind of look at is that if I did 30 degrees and I do the sine of 30, that's the opposite 1/2 over hypotenuse 1. So now I know that's my sine. If I do cosine of 30, that's the adjacent √3/2 over 1. So there's your cosine. So I'm going to kind of clean this up now and continue on. Okay, so cleaning it up, we said this will be root 3 over 2, and this is 1/2. And what we're learning is that the first one is your cosine and the second one is your sine whenever you do an ordered pair. Now moving on to the 45s, you could do the same thing, but back in the 45-45 triangle, we learned that that was root 2 over 2 and root 2 over 2. And then the nice thing about the 30s and 60s, you might have seen it when we did those patterns, is that they kind of flip-flop each other. And so this is 1/2, and this is root 3 over 2. So there's your first quadrant. Now, again, throughout this building of the unit circle, we've talked every quadrant has a 30, a 45, and a 60. And the ordered pair always is the same except for positive or negative. So remember, in the first quadrant, both numbers are positive. Second quadrant, you're going left and up, so x is negative, y is positive. In the third quadrant, both of your numbers are negative. And in the fourth quadrant, the first one's positive, the second one's negative. So now all you have to do is take your ordered pairs, and let's do the 30s first. So this is a 30, so we're going to take this ordered pair and write it here, root 3 over 2 and 1/2. It's the same order pair, except we are in the second quadrant, so make sure you make the x negative. Well, the same order pair goes here, root 3 over 2, 1/2, but this time both of them are negative. And then this one is root 3 over 2 and 1/2. The second one is negative. So once you have the first quadrant, you can just go ahead and basically copy all the 30s, the ones closest to the x-axis, then the 45s, which are out in the middle. So this would be root 2 over 2, root 2 over 2, first one negative. Down in third quadrant, the same, root 2 over 2, root 2 over 2, but now make both of them negative. And in the fourth quadrant, also root 2 over 2, root 2 over 2, make the second one negative. And then the last one, we're doing the 60s, which are the 1/2 root 3 over 2. See if I can squish it in here. 1/2 root 3 over 2, make the first one negative. Down here is 1/2 root 3 over 2, make both of them negative. And finally, 1/2 root 3 over 2, make the second one negative. Not the neatest, but it is the unit circle. So here's what a nicer or neater unit circle would look like. So notice they put the radians on the inside this time, then the degrees here and order pairs on the outside, but it represents the same information that we just talked about. Now, one of the things that students talk about is if they could just have the first quadrant, then that transferring of the order pairs around and positive or negatives becomes easier. So normally in the lecture, I show a little what I call a hand trick. And so if I draw a hand on here, it won't be very good, but you put your pinky along that line, ring finger there, middle finger goes there, index finger there, and then you'll have a thumb. So it'll look something like this. Your pinky and your thumb are on the X and Y axis, and I always put my left hand in there.
Staff, if you...
Sorry about that. So now we have the pinky and the thumb on the X and Y axis never get tucked under. So one of the things that you can do now is have your pinky there, have your ring finger here, middle finger goes there. Now tuck Now tuck your index finger under. And what you're representing is by tucking the index finger under, you were talking about the pi over 6 or the 30-degree angle. Now if you look, there's 1, 2, 3 fingers here, and you have 1 there. So notice that there's a 3 on top and there's a 1 on top. Now the square root of 3 is the square root of 3, can't do anything with that, but the square root of 1 is 1, and that's why it's just 1 on top, and then both numbers are a 2 on the bottom. So the hand trick would be if you tuck your index finger on under, you have 3 and 1. So you kind of would know that this is root 3 over 2 comma 1/2. And we can do the same thing with pinky finger, ring finger, tuck the middle finger under, index, and a thumb. Now you're referring to the pi over 4 or 45-degree angle. So you have 2 fingers on the left, 2 fingers on the right, and you'll notice both numbers on the top are 2s. So the square root of 2 is not a nice number, so we just leave it square root of 2. But the ring finger is representing the root 2 over 2, root 2 over 2. And the last one can be done also by tucking your ring finger under. So the ring finger is tucked under, index, or your middle finger, index finger, and thumb. So now it's 1 and 3 again. And if you look, 1 and 3. So when you look at the first quadrant, if you just did the hand trick by tucking under the index, pointer finger, middle finger, ring finger, count how many are to the left and to the right, it'll match your ordered pair, the number on top, everything's over 2, and then you just transfer it around. Okay, so what do we do with the unit circle? It says evaluate all trig functions at each location, and they want you to do it when t or your angle is pi over 6. So I'm going to find pi over 6 on the unit circle. It's right here. Here's the ordered pair. So let's write that ordered pair down. Pi over 6 is the same as a 30, so your ordered pair is root 3 over 2, 1/2. Now, what we learned on the unit circle is that that's your cosine and that's your sine. So when you do sine of t, I guess, cosine of t, and cotangent of t, sine of t then would be 1/2. Cosine of t would be root 3 over 2. And the cotangent, oops, I don't want cotangent. Sorry. I want tangent. What we want to know with tangent is that tangent is sine over cosine. And so when I do sine over cosine, I'm going to do 1/2 divided by root 3 over 2. Now, when you divide by a fraction, that's the same as multiplying by the reciprocal. So I'm going to multiply by 2 over 3. The 2's go away, and you have 1 over root 3, but we don't want root 3 on the bottom. And so I get root 3 over root 3 here. So 1 times root 3 is root 3. Root 3 times root 3 is 3. So there's my sine, my cosine, and my tangent. Ran out of room a little bit, so normally then I would do cosecant, secant, and cotangent. I wrote theta again for the angle. You can just do t. So the cosecant is reciprocal of sine, which would be 2 over 1, which reduces to 2. Secant is 2 over root 3, but now you have to rationalize that again. You get 2 root 3 over 3. And then remember with cotangent, don't flip this answer. Let's go ahead and flip this one. 1 over root 3. So that's going to become root 3 over 1, or just root 3. So there are your 6 trig functions. So I would like you to do part B, which is a DIY. Notice it's a negative angle. So start at the positive x-axis and go a negative angle, and let's see what you come up with. So remember, you're talking about negative 60 degrees. So you're down here where your order pair is 1/2 root 3 over 2. So the sine is the negative root 3 over 2. Cosine is the 1/2. Tangent, if you do sine over cosine, you end up with negative root 3. Cosecant, secant, and cotangent, you do reciprocals and do any rationalizing, and you get these answers over here. So I'm hoping that's what you got. Even or odd functions. Earlier this year we talked about even and odd, basically with looking at their graphs and seeing what kind of symmetry we had. And now with these trig functions, we're going to look at cosine and secant are even. So whether you're doing a negative input or the positive input, they are equal. Odd functions, the rest of them are odd, so you can see that sine and cosecant and tangent and cotangent go together. But the idea is, if you're doing a negative input into sine, you can go ahead and do the sine of that positive input and just put a negative in front. So let's take a look at this one now. If somebody's doing, for instance, the negative 30 and positive 30 end up being the same inputs. So evaluate the cosine of t, given that cosine of negative t is 0.3. Well, basically what this is telling you is that the cosine of t and the cosine of negative t are supposed to be equal, so cosine of t should also be 0.3. And if the tangent of t equals 2/3, find the tangent of negative t. So I'm going to have you do this one as a DIY, and then I'll put the answer up. So write out what you know from above and see if you can find what is the tangent of negative t. So you can see if you write out tangent of t is equal to negative tangent of t, then you can replace tangent of t with the 2/3, drop it in there, and your answer will be negative 2/3. So maybe you got it. Well, if you have some questions about odds or evens, talk to your teacher. So the next ones, we're talking about reciprocal functions and modes and doing stuff on the calculator. So we're supposed to find in the first one, what is the cosecant of pi over 8, and we're supposed to use a calculator. Now, first of all, cosecant goes along with sine. It's the reciprocal function. So instead of doing cosecant, because we don't have that button on our calculator, we're going to have to do the sine of pi over 8. Now with pi over 8, that's a radian measure. So when we go to our calculator, we're going to have to go back here and we're going to have to switch to radians. Or you can convert the pi over 8 into degrees. But now I'm going to type in 1 divided by the sine, and I can just type in pi divided by 8. And I get 2.6131. So I'd write down 2.6131. What if I asked you to do cosecant of 3? So remember, that one does not have pi, so it's not an exact pi. It doesn't have the degree bubble. What that is actually approximate radians. So I would do 1 over the sine of 3, because cosecant, again, is reciprocal of sine. So I can do 1 divided by the sine of 3. 7.0862. So something like that. All right, the next couple are some DIYs, so pause the video now, try those on your calculator and see what you come up with. So with these, you want to take your secant of pi over 5. That would be 1 over cosine. Again, you're in radian mode, so you should get approximately 1.2361. Remember example 4 here, you're in degree mode because we see the degree bubble. So switch to degree mode, and cotangent would be 1 over the tangent of 23 degrees. And then the last one, cosecant, again, you're back to radian mode because that's what we call an approximate radian. And you do 1 over the sine. You should get that decimal.